you, Ms. Ryono. Good morning, everyone. So thank you for coming today in spite of your busy schedule. My name is Kota OHASHI, and I'm junior of立命館University students. So I think there is no person who don't their complex. In other words, everyone has their weak point. So since I was schoolboy, I was very shy person. So I was not good at speaking in public like this situation. But one thing changed this weak point dramatically. It is a study abroad experience like this picture. So I learned the importance of being active through studying abroad experience. In last September, I went to India about for 10 days. So according to World Health Organization, it is said that about 97 million Indians cannot get access to drink safe water. So it is a serious problem in India. And I wondered whether I can be useful to India in terms of chemistry. So today I'll show the great technology of water purification by photocatalyst. At first, I must explain what catalyst is. Catalyst is defined as this sentence. In short, catalyst helps to change one chemical substance to another chemical substance. So studying abroad is not a chemical reaction, but I can say it is a catalyst for me in terms of changing my mind. So photocatalyst is a kind of catalyst, especially using light. So in many cases, people use titanium dioxide in terms of cheapness, stability, oxidation reduction power. So how is the mechanism? This figure shows the state of electrons in titanium dioxide. Electrons are in the valence band colored by blue. There is band gap between valence band and conduction band colored by green. In case of titanium dioxide, this number is about 3.2 electron volt, and it is equivalent to ultraviolet rays. So when light shines on catalyst, electron is excited to conduction band and electron hole is generated. This electron hole has a large oxidation power, so it produces hydroxy radical. In case of excited electrons, it produces superoxide anion. So these two chemical species have a large reactivity, so they are capable of decomposing organic matters. Nowadays, photocatalyst is used a lot in several fields. This is a self-cleaning technology. Like this movie, only by shining ultraviolet rays, it is possible to remove dirt. Of course, this technology is very nice, but what I'd like to say in this presentation is water purification by photocatalyst like this movie. Nowadays, researchers are developing this kind of photocatalyst, but there are some problems. Actually, researchers make self-cleaning technology practical, but water purification is not yet. It is because of diffusion coefficient. This number shows the tendency to spread. It means the larger this number is, the easier photocatalyst spread. That's why water purification has not been put into use yet. But I think this technology is efficient in India. So as long as sunrise, people can use photocatalysts. Actually, India faces an energy problem, so I also faced on power failure at the hostel in India. So considering the long term of development in India, I think people should introduce this kind of technology. So today there are mainly two kinds of systems about water purification by photocatalyst. The first one is dispersed system. The mechanism is to put titanium dioxide into reaction liquid. This system is very efficient because of large surface area, but it is necessary to collect minute particle after using. The second one is fixed system. The mechanism is to put titanium dioxide film fixed on substrate into reaction liquid. In this system, people don't have to collect minute particle, but the efficiency is less compared with dispersed system. So in order to solve this kind of problem, Panasonic developed new technology recently. It is a photocatalyst attached to zeolite. When people put this photocatalyst into reaction liquid and stir, these minute particles spread. And when people stop stirring, these minute particles recombined with zeolite because of electrostatic interaction. Therefore, people don't have to collect minute particle and people can keep its efficiency. Unfortunately, there is another problem. This is a sunlight spectrum. As I said before, titanium dioxide absorbs only ultraviolet rays. It is said that ultraviolet rays account for only from 3 to 5% of sunlight. As you can see, sunlight has a large intensity of sunlight in visible light region. So researchers are developing this new type of photocatalyst. As one of solutions, people introduce nitrogen dope. This is a crystal structure of titanium dioxide. When people replace oxygen atom with nitrogen atom, band gap will become smaller. Visible lights have smaller energy than that of ultraviolet rays. Therefore, it is possible to absorb visible light. So I have been talking about some problems and solutions in regard to water purification by photocatalysts. Actually, it is a little difficult to purify the large amount of contaminated water. But I'm sure that the day will come when people make this technology practicable and light makes world brighter in the near future. And finally, I want to be a catalyst for water purification in India in the future. Thank you for listening.